Good morning. I want to do a gas laws example problem with you guys, and I'm going to do kind of a complex one with multiple steps. Um, our problems are going to be a little bit more simple, but this way, if you have to do a complex problem, you have seen one before. Our problem is if there are 2 liters of gas originally at 40 degrees Celsius with a pressure of 500 torr, and the temperature increases to 55 degrees Celsius, what is the new pressure of the gas in atmosphere? So we're going to have to change units. And we're going to assume that the volume of the container remains constant. Okay, so since it mentions torr and then it mentions atmospheres, we need to know the conversion. So we need to remember that 760 torr is the same thing as 1 atmosphere. Okay, great. We also are going to have to convert, because you always are going to have to convert from degrees Celsius to Kelvin, and that's going to remember be 273 Kelvin is the same thing as 0 degrees centigrade. And it's on the same scale. So if I go up 1 degree Celsius, then I go up 1 Kelvin. Okay. And then something else we need to remember is that R is our gas constant, and that is 0.82057. 0.82057. I'm writing this down so I have them later. And that is the unit atmosphere liters over moles Kelvin. That's why we have to make sure to have our pressure in atmospheres and our volume in liters and our number of particles in moles and our temperature in Kelvin. It has to be those units, otherwise this value doesn't work. There are other versions of R, but this is the one that we're using, and those are the units we are going to use. Let's go ahead and start our problem. So I've got a sketch here for us, or a snip of that slide. So first things first is I'm going to write down what we know, right? So we know that volume is going to be equal to 2 liters originally. We also know that the temperature is going to be 40 degrees Celsius originally, which is going to be equal to, let's convert this, 273 is 0. So I just need to add 273 to 40. And that's going to be 313 Kelvin. Okay. I also know that I have a pressure original, and that is going to be 500 torr. So to get from torr to atmospheres, I need to divide by 760. So let's do that. 500 divided by 760 is going to be 0.658 atmospheres. Let's do thousandths place. Okay, great. And then I don't know, because remember our formula is PV equals nRT. I don't know what N is right now. I'm going to have to find it. I know what R is, I know what T is, I know what V is, I know what P is, but I don't know what N is. And I'm going to have to find N before I convert over to my second scenario. So let's go ahead and do that. So I know that if PV equals nRT, to get N by itself, I just need to divide by RT on both sides. So that's going to leave me with N is equal to PV over RT. I have values for all of these, so let's plug them in. Our pressure is 0.658. Our volume is 2. And then our R value, remember, is 0.082057. I'm going to have to squish. And then our temperature is 313 Kelvin. So let's plug that into the calculator. I'm going to do this I'm going to do this all at once, actually. And I'm just going to use parentheses. So I'm going to say parentheses 0.658 times 2 divided by, in parentheses, and then divided by new parentheses 0.082057 times 313, and then end parentheses. And that's going to give me an N of 0.0512 moles. So that's how many moles of gas I have. whatever gas this is, it doesn't really matter because it's going to stay the same the whole time. This is going to stay the same for both our scenarios. So now let's move over, and now we have to find out what our new pressure is. So our volume final is still going to be 2 liters, but we have a new temperature. Our temperature final is now 55 degrees Celsius, which is plus 273, 328 Kelvin. We know our N value is 0.0512. We didn't release any gas out of our system. We didn't take on any more. It's going to stay the same. But we don't know what P is, but we want it to be in atmospheres. So now we're going to take our ideal gas equation, PV equals nRT, and we want to get P by itself now. So that means we're going to divide by V on both sides. So this is now going to be P equals nRT over V. Let's plug in our values. Our N value we know is 0.0512. Our R value is 0.082057. And we know our temperature is 328 Kelvin. And we're going to divide that by our volume, which is still 2 liters. Let's plug it into the calculator. I'm going to do the same system as before and do it all in one line. So I'll do parentheses 0.0512 times 0.082057 times 328 and parentheses divided by 2. And that's going to give me a final pressure of 0.689 atmospheres. It's already in atmospheres because our R value had the unit of atmospheres. Okay, so this is our new pressure. This is our final answer. It's not that much of a change. We went from 0.658 to 0.689, but also we didn't change our temperature that much. 15 degrees as far as gases go, that's small potatoes. Hopefully this has been helpful. I'll see y'all in class as soon as this lets me